Okay, so let's do in class 5, number 3. So we have to show that the limit does not exist for this limit. So xy goes to 0, 0 of this function. This is my fxy. So to show the limit does not exist, we have to come up with two different paths that give us different answers. So to show limit does not exist, we must find two different paths that give different answers. Different answers. Okay, so I guess the most obvious path would be come along the x-axis or the x-axis or the y-axis. So what it looks like, well, let's try the x-axis first. Here's our circle. Our center here is 0, 0. So we're going to come along the x-axis, so the one here. So along the x-axis is path 1. Path 1 here. So along the x-axis, the y value is 0. And then x goes to 0. Okay, so then the limit then along this path would be, so you're going to put 0 in place of y, so the x cubed times 0 over x to the 6th plus 0 squared. So the top is 0, so the x goes to 0, be 0 over x to the 6th, and that limit is 0. So coming along path 1, we got 0 as our limit. So let's try and find a different path where we get a different answer. So we could try, say, path 2. So path 2, say this one we come along, we could try the y-axis, but I think that would give us the same answer. So let's actually try along here, say. So that'd be y equals x. Or you could say in general, y equals mx. So this one could vary. So the any line coming into 0, 0. So along this path then, along this path, then we'll have our limit. So now it's y then is going, so x is going to 0 and y is equal to mx. So in place of y, you can write mx. So the x cubed times y, but y now is mx over, that's going to be x to the 6th plus y squared, so the mx squared. So we get this guy, and let's work this out. So we'll have then limit x goes to 0, it's going to be then m x to the 4th over x to the 6th plus m squared x squared. Okay, let's keep going with this. We could factor an x squared out from the top and bottom. Let's do that. So factor out x squared. Doing that. So we'll have an x squared front here. We'll have an m x squared left here. And playing an x squared out here, we'll have x squared So subtracting 2 from 6 will be x to the 4th. That'll be an m squared and a w. The x squares will cancel. So we get then limit x goes to 0 of mx squared over x to the 4th plus m squared. And now actually, if we let x go to 0, the top will go to 0, this will go to 0, so it looks like it's going to be 0 over 0 plus m squared. So it's just going to be 0. So actually along this line, any line actually, we get 0 for any m value. So that's the same as the one from path 1, so we still haven't found one. But the limit should not exist. So limit should not exist, so we need to find the third path. So let's come up with the third path here. So path 3. So it's not obvious which one to choose necessarily. Yeah. Choose, so 0, 0. I'm going to choose a cubic function. We're doing this right. So that path would have y equals, say, x cubed. And then x goes to 0. Let's try that one. So in path 3 here, we'll have that limit x goes to 0. So looking at original function, so it'll be x cubed times y. So y is x cubed also. That's y. Over, that's going to be x to the 6th plus y squared, but y squared now is x cubed. So the x cubed squared. Okay, simplifying this, we get limit x goes to 0, the x to the 6th over, that's x to the 6th, so is that, so it'll be 2x to the 6th. But now the x to the 6th will cancel, so it just becomes 1/2. So this is different than 0, so we've shown we've got two different paths that give us two different answers, so therefore the limit does not exist. So hence, limit does not exist. So we're done.